going. ahead and get started. So, what we've been talking about so far are just normal numbers, normal solutions. However, when we get into some more complicated algebra, we start to see that sometimes single numbers aren't really useful for a solution. Sometimes we have more than one number. There's a few places we see this. For instance, let's think about our factoring. So let's say we have x squared minus 4. And focus in a minute now. It's having a really hard time. Hold on. I'm just going to restart it. Okay, that's easy to see. Okay, so again, let's say we have x minus 4. Now, in addition to this, let's add equals 0. Okay? Now, we want to solve this thing. So, what do we want to do to solve it? We need to get x by itself, so what's the first step? Add 4, yeah. So we add 4 to both sides. That's going to give us x squared equals 4. And then what do we do to get that square off of x? Square root. Good. So we take the square root of both sides. Now we have x equals what? That's true. There's another answer though. Does anybody remember? We've talked about it before. Negative 2, yeah. Okay. So this isn't just a single number. This is a set. It is a rule that governs what numbers x can be equal to. Okay? Now this is just one way that we can get a set, and this is a very, very simple set. It's just 2 numbers. But what we're about to see is that there are more ways that we can get these sets. Any questions before we move on? Okay, so I think we've talked about inequalities a little bit. Let's go back and review that some though. So let's say we have 2x minus 7 equals 5. Okay? So again, let's solve this one. What's the first thing we need to do? Yeah, add 7, good. So I'll add 7 to both sides. And so that'll cancel here, leaving me with 2x. And what's 5 plus 7? Is what? 12. Okay, next step. Divide by 2, good. Oops, that should be 12. And so that cancels, leaving us with x equals what? 6. Okay, so this is what we're used to seeing. Now let's change one thing about this equation. Let's make this 2x minus 7 is greater than or equal to 5. So we're going to just change one thing. Remember, what we've said about equations is that equations show perfect balance. So this is saying that 2x minus 7 is exactly equal to 5. This, on the other hand, is not an equation. This is an inequality. And inequalities do not show that perfect balance. Instead, they show weight. So this one, since the mouth of this inequality is pointing to this side, or in other words, greater than, this says that 2x minus 7 is weightier or bigger than 5. So we need to come up with an answer for x that will make this true. All right, well, we solve it the exact same way. So again, add 7 to both sides. That cancels, giving us 2x is greater than or equal to 12. Then we divide by 2 on both sides. We have x is greater than or equal to 6. So we essentially get kind of the same answer, but it's said in a way that actually gives us more than just that 6. So let's think about this on a number line. This answer right here, x equals 6, we put that on a number line. Our 6 is right here. It says this is exactly equal. That's it. That's all we have. However, if we draw this on our number line instead, x is greater than or equal to 6, then what we see is x is not only 6, but all of the things bigger than 6. So as long as we plug in something larger than 6 or equal to 6 into x, it'll make this thing work. Any questions? Okay, so remember, this is what we call an inequality. And they don't show balance, they show weight. Any questions? All right. So let's add something new to this then. I believe we've talked about absolute values before. So what is the absolute value of negative 6? Yeah, just plain old 6. Of course, what we do when we have an absolute value like this is we look at not the sign of that number, but the actual value, or its distance from 0. So in other words, 6 is 6 steps from 0. So 1, 2, 3, 4, 5, 6. And it doesn't matter whether it's negative or positive, it's always going to be the same distance to 0. So absolute value is asking for the, like it says, absolute value. What is the actual intrinsic value behind this number? Okay? So then we also said that we could solve things with this. Same thing like maybe x plus 2 is equal to 4. Okay? Now remember, what this is saying is that whatever's inside of here, whatever x plus 2 is, its absolute value is going to be 4. So ignoring that we have equal to 4 here, if the absolute value has to be 4, what are the two things that x plus 2 could be? If we take the absolute value of this and we get 4, what are the two things that this could be inside of here? The whole thing. So if the whole thing comes out to 4, the whole thing could be what two numbers? X plus 2 could be 4, because the absolute value of 4 is 4, or x plus 2 could be negative 4, because the absolute value of negative 4 is also 4. Does it make sense? Yes, no, maybe? No? Okay. So let's go back and think about it. If I just had x in my absolute value, and it was equal to 1, okay? Take this x out of that absolute value. There are two things that x could be. in order for us to get a 1 out from its absolute value, right? What are the two things that x could be? It could be 1 and it could be negative 1. Again, what we're focusing on here is the thing on the inside. What could this thing on the inside be that would give us this? So here, what could this thing be? What could x plus 2 come out to be in order to give us this when we take the absolute value? So x plus 2 could be 4 in order to give us this absolute value 4, or x plus 2 could be negative 4 in order to give us this 4 on the outside. Does that make more sense? Okay, good. So now we can solve for both of these cases. So let's go ahead and solve. Pretty simple. What do we do? Yeah, subtract 2. It's minus 2 to both sides. That means that here x could be equal to what? 2. Okay, same thing on this side. Subtract 2. That means x could be what on this side? Negative, it's negative 6 and negative 6. Negative 4 and negative 2 combine to make a bigger negative number. It makes negative 6. So for this, we can say that x can be equal to 2 or negative 6. Okay, so again, let's replace this equal sign with one of these inequalities and see what happens. Before we do that, though, are there any questions? No, this makes sense to everybody? All good? Okay, so again, let's replace this with one of these inequalities and see what it looks like. So instead, we'll have x plus 2, absolute value, is, let's say, less than or equal to 4. Okay. So, again, in order to get this 4 out, there's two things that x plus 2 could come out to be. It could be positive 4 or it could be negative 4, right? So x plus 2 could be less than or equal to positive 4. However, x plus 2 could also be negative 4, right? But there's a problem now. And this is a very important problem. Be sure you pay attention to this. Remember that an equation shows perfect balance. It will always have this be the same value as this. Inequalities do not show balance. They show weight. Okay? So when I make this one here, this is basically the same as that, right? 4 and positive 4 are basically the same. But when I make this negative 4, that's no longer, yeah, something's changed here. In fact, our weight has changed because I've made this negative. And I have to show that that weight has changed. So the takeaway here is that when you write these out, so when you split this up as two parts, one where you have it equal to a positive, one where you have it equal to a negative, when that sign changes over there, you need to make sure you show that the weight has changed as well. Any questions about that? Okay. So let's go ahead and solve this now. Of course, it's solved the same way, minus 2 to both sides. So x could be less than or equal to 2. Subtract 2 from both sides. And x could be greater than or equal to negative 6. Okay, so just so this makes a little bit more sense, let's graph it and see what this solution looks like. So 0 in the middle here. We have a solution starting at 2, so I'll mark 2 here, and it can be equal to, so I'll use a solid dot. We have another solution that starts at -6, so it's probably about right here. And again, it can be equal to, so I'll use a solid dot. Now then, x must be less than or equal to 2. So is x on the right side or left side of 2? Which side is less than 2? Left side, yeah. X must also be greater than or equal to 6. So is that on the left side or right side of -6? Yeah. So what we end up getting is a line between these 2 points here. So any of these numbers between -6 and 2, including -6 and 2, could make this true. Let's go ahead and try that out. So let's pick just a random number. Let's say -1. It's within our solution, so it should work. So if I plug -1 in for x, I have -1 here, so it's -1 plus 2. One. What's the absolute value of 1? 1. Is 1 less than or equal to 4? Yeah, that makes sense. 1 is less than 4. Okay. Let's choose another number that's in our solution set. 0. So 0 plus 2 is what? Absolute value of 2? 2. Is 2 less than or equal to 4? Yeah. Okay, now let's choose one outside. So something like 3. So plug 3 in for x. 3 plus 2. Absolute value of 5. Is 5 less than or equal to 4? No. So we can see that as long as we're between these two numbers, we're fine. But as soon as we go outside, it doesn't work anymore. Does that make sense? Good. Any questions? All right. Let's try some more. Let me give you this one. 3x plus 2 is, let's make it an absolute value, yeah, is equal to, let's say, 7. All right? So let's solve this one. So we need to break this up into 2 parts. What's the first part? Is what? Okay, so the absolute value would give us 7. So 3x plus 2 could be what? 7. Or 3x plus 2 could be equal to -7. Now, do we need to worry about flipping any kind of signs here? Do we have weight or do we have balance? We have balance. So we don't need to worry about flipping anything. There's nothing to flip. All right, so we can go ahead and solve this. So what do we do? -2. That gives us 3x equals what? 5. Next. Divide by 3, so that gives us x equals what? Just make it a fraction, don't give me a decimal or anything. Yeah, 5/3. Okay? Same thing on this side. So -2. That gives us 3x equals what? Negative 9. Okay, divide by 3. We have x equals what? Negative 3. Good. Any questions? All right. Let me change one thing about this one. Oh, whoops, x. I'll rewrite this. Oh my gosh, I'm messing up. Okay. Negative 3x plus 2 absolute value is equal to 7. Okay, so I've changed one thing. I've made this a negative 3. Let's see how that affects this. Okay. So, same thing, right? We need to make this into two parts. Negative 3x plus 2 could be what? 7. And negative 3x plus 2 could be what? Negative 7. Whoops, equal to negative 7. Whoops. Okay. So, solve. Subtract 2 from both sides, right? That's going to give us negative 3x equals 5. And then divide by negative 3. We get x equals negative 5 over 3. Same thing over here. So subtract 2. We get negative 3x is equal to negative 9. Divide by negative 3. And we get x equals positive 3, right? So essentially, by adding that negative to the 3 here, I have flipped the signs on my solutions. Things are flipping around. Okay? So we need to keep that in mind when we go into the next one. Change one more thing about this, and that is negative 3x plus 2, absolute value, is less than 7. Okay? So let's try this one. Again, we need to set up two scenarios here. What's the first scenario? Good. And careful, what's the next one? Perfect. Why do we put that greater than there? Good, good, everybody. We have negative 7 here. We have flipped our weight. It's because of that negative that is flipped. Okay? Now I'm going to give you a hint here. It's going to flip again. Let's see when that happens. So let's start solving this. What do we need to do to start solving this? Minus 2. Okay? So now we have negative 3x is less than 5. And now what do we do? Do what? Good. So when we divide by this negative 3, since we're dividing by a negative, notice that this side starts negative and becomes positive. This side starts positive and becomes negative. Our weights have flipped, so we need to flip that side. Excellent, good. So that's one half of this. Let's do the other half. Of course, same thing, same process, minus 2. We get negative 3x is greater than negative 9. And then again, we're going to divide by negative 3, so what's going to happen? Yes. We divide by a negative number. And all of a sudden, the values of our sides has flipped. This side started negative, is now positive. This side started negative, is now positive. So we need to flip that sign. So again, let's go ahead and graph this, just so that we can see what this solution looks like. Okay, so we've got 0 in the middle. 3 is about right here. Negative 5/3 is about right here. Okay, and we cannot be equal to either of these numbers. Okay, x has to be bigger than this number and smaller than this number, so we have a line in the middle. Make sense? All right, so let's test out some numbers then. Some numbers in our solution. We know that positive 1's in our solution. So let's go ahead and plug that in. So positive 1 in for x. What is 1 times negative 3? What is negative 3 plus 2? Okay, and is that less than 7? Yeah, so that works. Okay, so that works. How about negative 1? Negative 1 in for x. So negative 1 times negative 3. Yeah, it's positive 3. And then positive 3 plus 2? 5. Is that less than 7? Good. Okay, let's choose one that's outside. Something like 4. 4 in for x. So negative 3 times 4? Negative 12 plus 2? Is what? Negative 10. Absolute value of negative 10? 10. Is that less than 7? No. Okay, so our solution set works. Any questions? None? All right. Doing pretty good. Let me try this one on you. Excuse me. Negative x over 2 minus 8 is greater than or equal to 12. Okay, we want to solve this one, so we need to set up two situations here. So what's our first situation? Negative x over 2 minus 8. Good. And then what's our second one? Perfect. Good. So we flipped that inequality sign because we had a change in our weight. Good. start solving this one. What do we do first? Okay, plus 8. All right, and that's going to give us negative x over 2, then what? What's our inequality? Good, no change in it, and then this is 20. All right. So now, what do we do? Multiply. What are we going to multiply by? Yeah, we could also take the negative along with it, couldn't we? So let's go ahead and get it all in one. So let's multiply by negative 2 on both sides. That doesn't look like multiply, but it's multiplied by negative 2. So that'll cancel here, leaving us with x. Then what do we have? Careful. This one? Is it going to change or stay the same? You sure? Think about this. Yeah, we started with a negative on this side, and now we have a positive. We have changed that through multiplying by a negative. This one, we're multiplying by that negative, it's going to be negative 40. So our weights have flipped because we multiplied by negative. Just like if we divide by a negative, if we multiply by a negative, this also has to flip. It's because it's changing our weights. All right, so let's try this one out. Again, we add 8 and add 8. So this is going to be negative x over 2 is still less than or equal to 20, or I'm sorry, not 20. What did we get here? Is what? Negative. I can't hear you. 4? Okay. Everybody's got masks on, so it's hard to hear everybody. Okay. So now we need to do what? Multiply. So we're going to get x is what? Greater than. Good. Then what? Is it negative? Positive 8. Yeah. Good. What questions do we have? None? Okay, let's go back, make something a little bit simple. Absolute value of x plus 3 is greater than or equal to 0. Okay? So what do we have when we try to solve this? X plus 3 is greater than or equal to 0. Do we need a second case? No, because there's no such thing as negative 0, right? Good. Okay, so all we need to do is subtract 3. And x is greater than or equal to negative 3. Good. Any questions? Okay. Now let's look at this. Absolute value of, let's say, same thing, x plus 3 is less than negative 2. Okay, now let's think about something. if this were absolute value of x plus 3 is equal to negative 2, what would we say about this? Think about it. We have an absolute value equal to a negative number. Can an absolute value give you a negative number? No. Okay. So because an absolute value cannot give you a negative number, here we say this is undefined. Okay. Similarly, this absolute value here, is there anything that this could possibly come out to be that would be less than negative 2? Can we have an absolute value that would be less than a negative? No. It can't be equal to a negative, and it can't be less than a negative. So this one is also undefined. What about absolute value of x plus 3 is greater than negative 2? Yeah, that would work. There are things that we could plug in here that would make this work. Okay, now let's try this out and see what happens. Okay, so we have x plus 3 has to be bigger than negative 2. Do we need a second case? No, we do not. Because there's no possible way to make that second case work. It wouldn't be something that would be greater than negative 2. So this is all we need. Okay, so we just subtract 3. And x must be bigger than negative 5. That's the only way that we can get this one to work. Does that make sense? Okay. So a few things to keep in mind about this last part here. If we've got this thing equal to, or less than, or greater than 0, you only need one case because there's no such thing as a positive or negative 0. It's just 0. Absolute values will always come out to be quote-unquote positive. So they can't be equal to a negative, and they can't be less than a negative. However, they can be greater than a negative, because all positive numbers, all absolute values, are greater than negative numbers. But we only need one case. We don't need a second case. Any questions? All right, then I believe that will do it for today. I've been told that no one got the grades that I sent out, so I'll send them out again, just to make sure everybody gets them. But again, looks like everybody passed that exam, so good job.